Hola, I'm Oscar, advisor of BitCherry's. On previous video, we talked about what is consensus and we learned about BFT and ABFT. Today, we'll learn BitCherry's consensus mechanism. In the last few years, the so-called blockchain technology or distributed ledger technology (DLT) has developed rapidly. In particular, the increase in value of Bitcoin and other cryptocurrency, as well as the global success of some large initial coin offerings (ICO), has sparked public interest in development in the digital world. One of the particular interesting aspects of blockchain technology consists in the decentralized consensus building, achieved by the application of various consensus mechanisms. Most blockchain projects use one of the three currently most common consensus algorithms: proof of work (POW), proof of stake (POS), or delegated proof of stake (DPoS). We also know it DPoS. All these mechanisms aim at ensuring that all participants dispose of identical copy of the distributed database files. Proof of work. Most of us will have heard of a POW, especially since the first public blockchain, Bitcoin. Bitcoin used POW. In this example, POW is explained with Bitcoin. POW is conducted through miners competing to solve a cryptographic problem also known as hash puzzle. These miners help to verify every Bitcoin transaction where it involves producing a hash-based POW that is based off previous transaction blocks and forms a new branch with a new transaction block. This means that the work is moderately difficult for the miners to perform, but easy for the network to verify. The first miner who managed to produce the POW will be then awarded some Bitcoins. Over the time, the amount of Bitcoin awarded decreased over time. And over the years, as the difficulty level in mining Bitcoin has increased tremendously, resulting in POW being notorious for the amount of energy it requires to keep the blockchain running. So now we talk about proof of stake (POS). Unlike POW, where new transaction blocks are created based on computational work done by solving a complex cryptographic puzzle, but POS allows a forker to stake any amount of cryptocurrency she has, to be probabilistically assigned a chance to be the one validating the block. The probability based on the amount of cryptocurrency staked. Additionally, for most POS systems, instead of receiving a cryptocurrency reward, the forker instead takes the transaction fee as a reward. The idea of putting coin to be staked prevents bad actors from making fraudulent validations. Upon false validation of transaction, the amount staked will be forfeited. Hence, this incentive forkers to validate legitimately. In the recent years, POS has gained attention, with Ethereum switching to a POS from a POW consensus system. Okay, next we talk about DPoS, delegated proof of stake. DPoS is similar to POS in regard to staking, but has a different and a more democratic system that is said to be fair. Like POS, token holders stake their tokens in this consensus protocol instead of the probability algorithm in POS. Token holders within a DPoS network are able to cast vote proportional to their stake to appoint delegates to serve on a panel of witnesses. These witnesses secure the blockchain network. In DPoS, delegates do not need to have a large stake, but they must compete to gain the most votes from users. It provides better scalability compared to POW and POS, as they are fully dedicated nodes who are voted to power the blockchain. Block producers can be voted in or out at any time, and hence, the threat of tarnishing their reputation and loss of income plays a major role against bad actors. No doubt, DPoS seem to result in a semi-centralized network, but is traded off for scalability. Like POS, DPoS has also gained attention over the years with several projects adopting this consensus algorithm. Since it was invented by Dan Larimer, DPoS has been refined continuously from BitCherry's to Steam and now in EOS. Okay, now we'll go for the detailed explanation about BitCherry's consensus algorithm, ABFT, and POUC consensus algorithm. The disadvantage of ABFT algorithm is that it does not achieve complete certainty of the consensus. It just decreases the probability of tampering with time, forming the final certainty. So the time for consensus determination is also related to the number of nodes. All nodes participating in the transaction participate in the consensus, which also limits the TPS of the hash graph from the aspect of network bandwidth and CPU or GPU computing power. Therefore, in BitCherry consensus mechanism, BitCherry's data structure is based on the hash map. It is the blockchain pioneering technology with 6-degree separation theory, which demonstrates the value of POUC user, select consensus node, optimize the network propagation consensus process. Current system is combined with BitCherry original P2+ network protocols and multiple types of application BitCherry sidechains, which allow to create a unique ABFT and POUC consensus. It is different from the depose method. All users can participate in the POUC consensus. The algorithm automatically selects neighboring nodes and non-neighboring nodes to virtual voting according to the relationship graph algorithm and refers to their weights for virtual voting. The selected nodes will receive accounting rewards. The selection rule of adjacent and those nodes are based on the node network bandwidth or delay, the closeness of the main or sidechain relation hash graph, and the bit U value of the node. In simple terms, BitCherry consensus algorithm is based on ABFT, so any node that satisfies the condition can participate in the process of the whole POUC consensus. And almost all important nodes in the circle will also participate in the POUC consensus process. Thank you for watching. That's all for today, and see you guys on the next video. Thank you.